Yes.
So let me give you a quick introduction, guys. Thank you for being here. The next speakers is a group of folks that, if you are, let's say, active in the Bay Area community, you probably have met a few times. Prashant, Ashwin, and Sai. Prashant is the OWASP leader, so he can maybe more tell you about that. They have like 3 hours workshop focused on practical street modeling. So I'm sure they have a lot of things to share with us and can hopefully learn something new. Right. Let's see. Thank you.
Thank you. Hey guys. Hi, my name is Ashwin, and I work at Visa, and I do threat modeling for M&As specifically. So I'm the person who's going to bore you with a bit of theory and introduce you to a bit of tools and all. And these my friends, Prashant, Swajan, and Sai. These are the folks who are going to be the interesting guys who's going to walk you through the hands-on stuff. Right. So if you guys are ready, we can get started. And absolutely, this is not a presentation by any chance. This is a workshop. We want you guys to be interactive. Let's have to and fro conversations. And the idea is not to teach you what threat modeling is. I'm sure people do understand what it is, and most of you would already be doing it in some way or the other. The idea is to just trigger your mind with our aspects of what we have learned in the industry and how we can make it better. And the focus would also be a bit on agile threat modeling, right? That is something I believe most of the folks sort of struggle. That is where we are here to help you guys with that. Right. So this is the table of contents, right? How we would be going for. So now, right, the main thing that I want to focus is don't hesitate, right? In none of the question is lame or anything that is quite basic, right? Let's discuss whatever you guys have in your mind, right? Yeah. Okay. So this is something that I would want to focus as a Bible, and anyone who does modeling is something they would want to do it as well. Is there a way where even a code is being written? Can we identify any vulnerabilities or threats for infrastructure, right? And what is the thing that you guys think of, right? Where should a threat modeling really start? Any idea, guys? Like when do we start? Right. So let's say your team is going to build something, right? And you're the primary architect responsible for the team. So when do you think we should do the threat modeling? Is it the phase when they planning project like that? Exactly. Yeah. So as early as possible, right? To make it very simple, as early as possible. But what is the definition of being early? Right? Every industry is quite different. Teams are quite different. Some teams might have a weekly cycle, some team might have a quarterly cycle. But what does early really mean? Right? So ideally, when the project teams they have a plan that they are going to work on something, that is the best time to get in between those calls. And I know it's very easy to say it, but how do we allot time, right? That is where you have to work with those program managers to tell them that what is your requirement from an architecture perspective, when and how can you provide inputs to the team, right? So when they have something at a playground level that, okay, this is what we might be developing, let's say 2 endpoints, right? 5 infrastructure is what we might be deploying on. So that is the phase where you give your security requirements. So that way, at a later time, and when you compound that with multiple reviews at a later stage, that's how you become a. So I'm sure, right, all of you would have learned about all of these keywords, right? Threats, risks, and vulnerabilities. And we sort of, most of the time interchange these keywords and not really understanding as to what does a threat really mean. Let's say a person or a team is going to create a new file upload, right? Would you look for threats or would you look for vulnerabilities? That's the main question. So what do you look for in that case? So vulnerability is associated with the software or would it be a threat? So in your use case, what do you, or in your case, what is it that you want to fix from a security perspective if it's a file upload?
Starting phase, I'll always see these are the files, these are the requirements from my side. And this is the type of file I want to upload. From that perspective, I look at the threats.
Perfect, right? So we are looking for a threat perspective. That a threat is an internal or an external attacker, depending on the use case, where the file upload feature is being rolled out to, right? And malicious file can get executed, and again, depending on the use case, again, what is a malicious activity that can perform, right? So we are actually focusing on the threat first, right? So threat is nothing but something that is dangerous that can be a potential threat into a system, right? And things that we hear about in the market are, criminals and malwares and phishing attacks and whatnot. So those are threats which can cause impact to the organization, right? Now vulnerabilities are very specific. So in your case, when you mentioned that okay, it could be file extension, I'm expecting an JPG image, but a person is able to upload a PHP file, depending on the text file, obviously, right? So those are specific vulnerabilities which you want to tackle, right? So mitigation for each one of those would totally differ, and that is what we will sort of learn as and when we go there, right? And risk is something is for the organization itself, and the risk is not at all limited to the software or what feature is going out. This could be a brand image. Let's say you're a big firm, right? Even a small downtime, it could be a loss availability. That could be a reputation impact or a risk against that. So that is something we need to be cautious as to which terminology do we use at which use cases and how do we convey that to the teams. And that is the toughest job, being an architect. So actually communicating it with different teams, it might be a team lead or an engineer versus a manager. How do you communicate what information to what? So now this is something that I would want everyone to focus a bit more. And I would surely believe that this is one of the major things most of the time people sort of miss out while doing security reviews. Right? Again, coming back to any releases, right? All security reviews are tied up to a release or a project or an entire entity, whatnot, but it's still a project in the end. But we sort of miss out on the larger scope as to why even an attacker would really want to hack your system. So that is where we need to really understand what can really go wrong, because that is what can actually help us in terms of identifying the scope. Right? Let's say it's a huge deployment of entire e-commerce being uploaded. As an attacker, what do you think is behind cases? As an attacker, and again, we don't have a definitive answer, but since you want to sort of give it a, it's an e-commerce system, let's say, and what do you think an attacker will go for? Why do we does he even want to attack your system? What is his obviously, right? So now we know what is he going for. It's always important to really understand the enemy. That is one of the reasons if you go for MITRE attack framework and whatnot.
Just a second, I'm sorry to interrupt. They're going to do the raffle now, so if somebody want to go, you guys have a ticket. If you want to stay here, you can write your name and I'm going to do it for you. I'm not going to cheat. I'm not going to take your presents. So yeah, just to let you know. Thank you. Yeah.
Yes. So going back to the MITRE attack framework, so that is the reason we have got different APT groups. That's the reason why each enemy or each APT groups have a definitive way of going for specific industries. There are specific APT groups only for fintech, specific entities for government organizations, because they are certainly looking for a specific type of information or something credible to hack onto. Right. So that is why we need to figure out and really understand the enemy and your scope as well, what you're really trying to protect. Right. Second example, what I would maybe want to is like predicting the attack vector. So again, coming from an e-commerce, where do you think the attack vector could really lie on? At a very high level. Again. So one would be profile pages, maybe people want to enumerate. That is where your credit card information might be stored. Second would be phishing attacks. Because attack vectors is I really want to get access to the customer itself. So one of the attack vectors would also be phishing, right? So really understanding your application is quite crucial, because that is where it will actually tell you what kind of attacks can be exploited on your servers. What is it that you really want to secure? And the main idea is also to be proactive, right? Once you understand who can really attack, what information are they really behind, right? And looking at specific attack vectors, that is where we could be proactive in terms of our defenses. So again, this is nothing new. I'm sure people would have read about it tons of times. And Again, we are not trying to put an evaluation where what went wrong at that point, but again, just a feedback like what could have been done better. Example, the target breach which really happened, right? If they had a comprehensive threat model, right, where they could have actually looked at the vendor acceptance criteria and controls, right, I'm sure it would have not been that bad, obviously. And it's always easy to comment out when something has really gone wrong. So now, just to focus a bit more on why do we really need threat modeling? Again, we spoke a bit more about attacker's mindset and a couple of stuff. So, as per your opinion, right, why do you think we really need threat modeling? Where does it really going to help? Apart from the slide, right? Slide is just bunch of keywords.
Identifying starting.
Okay, and why do you want to do it that? We do have tons of controls in place, tons of policies. Every company has got its own policies, benchmarks, and whatnot. This is how you should deploy your Linux servers and whatnot. But again, still, why do we need it?
Save time.
It's also just to fix it early. That's a major case. It's not that other tools can't do it. It's only that it's way too late. Most of the time, it's already in production, and that cost and the time they're going to invest on fixing it is a big thing, right? And what other use cases can you think of? One was saving time and money. What else? Anything else that you can think of? Compliance factors, right? Most of the time, tools are compliant, SOC 2, whatnot. That's how they market. Obviously, that doesn't mean they are not. But again, human manual intervention to really understand based on a specific scope, use case. Let's say your company is going to deploy something in Europe. Obviously, that changes the entire landscape as to how you are going to evaluate something right now, right? And third is having that feedback loop, right? You again want to go back to your blue team to say that it's something that we observe as a company or the threat groups. We are from a fintech background and whatnot. Having that in an entire loop being closed, being proactive in nature. And again, this is quite basic. And again, there are tons of frameworks, and the idea is not to promote only Stride, but since it's one of the standard framework, people have been using it over the years. Microsoft came up with it, years back. It is quite standardized and it really works, obviously. So just to introduce a bit on Stride, if you are not aware, right? So Stride is an acronym that stands for, identifying different type of threats, spoofing, tampering, reputation, information disclosure, DOS, and elimination of privileges. So spoofing, right? So we really understand as to spoofing, what does it mean, right? The definition typically means that a person can be impersonated, right? But now we really need to understand, given an architecture diagram, right? Let's really assume a simple FTP use case. Let's say it's going to be deployed in your environment, and it's a business use case that is not an answer that is going to be taken by the management that we can't deploy FTP. It has to be done. It's a business use case. Customers are, banks are relying on that. So now that has to be done. So where do you think spoofing can really happen? So consider the actors in the architecture would be your endpoint, a network which goes to a server. Again, that's an internet connection. Again, going back to the FTP server. So where do you think spoofing can really happen? Because we all know all of these keywords. So understand the keyword is not a problem. More about understanding where do we really apply those. Any guesses? Again, there's no right and wrong answers, right? There's no prizes from our side. But yeah, anything that you can guess, that will help. So do you think spoofing can happen over the network? Is it really applicable on the network? So there are multiple actors, right? One is the endpoint where the banks are going to connect. So that endpoint. Then there's a network, obviously, how they will connect, right? And then there is a server which is sitting inside your perimeter, which is serving as FTP, right? So now, given a simple scope, client IP scope, right? So on the network, there are now three different actors, right? So let's say now, do you think we can apply spoofing on the network? It's really possible. Or are there other criteria that is more applicable than that? The idea is not to force Stride on each one of those, but which is more applicable so that we can really put a control against it. Ideally, no. Ideally, on a network, spoofing doesn't happen because network is just going to carry your data. So what do you think is much more valid in that case? Tampering, right? Because the network could be snipped, someone can really tamper it and again forward it to the client or the server. So that is the main idea of implementing any threat model. You can do Pasta, Octave, MITRE ATT&CK, whatnot. But the main idea is to really understand the logic behind which type of threat is really applicable to the given actors in a given environment, right? So any questions or anything that you want to discuss on this? Again, it's not a presentation, it's a workshop, right? So anything back and forth that you guys think?
Why is IP spoofing not possible?
So IP spoofing is still going to start from your endpoint. We are just focusing on the data once it is on the network, right? So taking a simple scenario. Again, it's not about what cannot happen. It's more like just to start with, where do you restart your threat model? Obviously, there is no end to any threat model. You can keep doing it till ages, it will still not be correct. It's more to, mitigate with high impact attack vectors so that your company is safeguarded. Obviously, right, there are other controls to do so. But once the data is on the network, it's going to be always on the endpoint who receives it for IP spoofing and whatnot. That's where your firewall or other IDS, IPS will help you. Either it's going way too well, people are really understanding it. Okay. So now this is something very specific to Agile. I'm not sure if you guys have already heard about it, right? There's something called as rapid threat prototyping. Have you heard about this anytime? Have you used it? Anything that you want to share? What is it like? How different is it from, let's say, standard stride or anything?
So I can say it's a targeted rather than a system.
So the major difference why rapid prototyping is really used, or let's call it as RTP, right, to make it simple, it goes to the principle of 80-20, right? Like aim at 80% of the security benefit by focusing on 20% of the scope. Because when you are in agile environment, it's not quite easy, right? There are releases every day or every week, and with multiple releases. You can't do a deep dive or detailed stride on everything. But that is where these things really help, right? So how does this really work? Again, as an example. So let's assume a 3-tier architecture, right? You have got your browsers, users who are entering your premises. Now you have your first internet boundary where it reaches your web server, right? And again, your web server is connected to the layer 2, that is your database, which is on your restricted zone. So that visualization is clear, that is on our, right? So you sort of mark things which are out of your control. That is the browsers and users. So those are sort of out of scope because we don't control them, right? Now you mark anything that is critical, that is your data stores, which has your most critical values stored. You give them the highest rating from 10, 9, whatnot, because those are your crown jewels, right? If you guys are not aware of what crown jewels is, crown jewels are something that you really want to protect at any given cost for every organization. And depending on the nature of business, healthcare would have different type of crown jewels, fintech, and vice versa, right? So that is what we really want to protect. So in this case, data stores ideally, because every data is being stored over there, that will have your highest criticality. That's what you really want to protect. And then anything on layer 1, that is a web server, can never have the same criticality. It will be downsized. So main idea is let's protect the most important ones. So in this case, the data stores. For that, what are the controls? So for that, again, you start with stride, but again, not putting all the controls, but the most critical ones. So one is restriction of privileges, right? Nothing beats restriction of privileges. Those could be your remote code executions or IAM bypass, IDOR, and whatnot. Right? Those are the most critical ones. So you start applying those. Second is availability. Another company today is in a state where they don't want to have 100% availability, right? Everyone wants 100%. So those two become your first aspect. So you start to apply restriction of privileges and DOS mitigations on all of those. And then same thing on different layers. Once you are done with that, at least nothing can be as bad as what it should be. Other things can still be mitigated, right? So that is how rapid prototyping is actually being used. Any questions on this? So stride is, it doesn't consider the severity of the assets. We just apply stride everywhere. But in RTP, you don't have time. So idea is to do with threat modeling using criticality of assets. That's a major difference. So this is one way, right? So again, this doesn't stop over here in terms of doing threat modeling for your agile methodology, right? This is the type of threat modeling that you do. And again, where we really want to go ahead is like one step back. So as an organization, if you don't have any threat modeling for agile, you start with rapid RTP. And then once you are done with that, you really want to go with agile abuse stories. So what does that mean? Every company has some form of Jira or any management, I'm sure. It could be any other tool, but the concept still exists, right? Every team, they would sort of have their epic. Inside that, they'll have multiple stories and what they want to go out. But that is where, if you want to go back to our conversation where we started, right? Like being early. So the moment the team has, their own scope ready as to this is what we want to release to production, right? So we have to go back and write our own abuse stories. So what does that mean? Let's take a very simple example. You want to have a file upload, again, same exact scenario. So as a development team, they would come back with a story saying that one of our customers, XYZ location, they are requesting this kind of feature, right? And that story ends over there. But we being the architects over here, we want to have those abuse stories ready. So our main idea is to define what can really go wrong. This is where we put our attacker mindset, coming back to the same initial ideology that we had, right? So how do we really write those, right? So we really have to understand the scope again. Not every scope will have the same kind of attacker base. So when we say attacker base, nothing but the personas, different kind of people who can get into the system. It could be insider threat or it could be normal hacker from the perimeter, right? Second is those scenarios. Like what is that exact vulnerability in this given scenario? Is it a IDOR? Is it some kind of infrastructure loophole which can go wrong? Right. And third is the impact, which I believe most of the time we really miss as to what can really go wrong. Right. Saying that, this impact could be, again, coming back to the risk criteria. It could be a brand abuse. It could be availability issue, right? It could be loss of data, right? All of those, right? And last is how do you want to have those mitigations in place? This can surely come from your, company's controls in place or standards that you already have in your infrastructure, or you can follow any, industry standards as well. Any questions on this, guys? If you want, maybe you guys are up for it, maybe we can have a quick 5 minute discussion. Let's say currently we only have username and credential as the existing way of users being authenticated. Now the team is coming back saying that, okay, we want to upgrade it to MFA. So now that is the user story that they have. So how do you guys want to write those abuse stories? And again, there's no right and wrong answer. As long as it's right, as long as we cover who is going to attack, what can really go wrong, what is the impact, and fourth is how do you want to mitigate? Any guesses? How do you want to structure it in terms of all of these 4 factors? Okay, in your case, insider is a first persona. Got it. What is the scenario? They are going to use an unapproved software. Okay. What is the impact with this?
Like they can sell the data, whatever, because insider not get the access to right the data. That person can sell the data or can give the access to the unauthorized. That can be the impact.
Okay, so impact is stolen data. Right? And how do you want to mitigate this?
Verify the device. employees. Whatever.
Now it's real time. Let's say your employee has got company has got 500 employees, right? So everyone is already approved employees. Yeah.
Stock audit for third
For
party.
that, we can't call an audit right now.
Like-
Right? People are going to go live in a month now. Getting an audit is not going to be that easy, right? Calling a vendor and tons of stuff. Every team has to be ready. Did I win?
So nobody won. I'm sorry, guys, and I'm returning them. There's going to be like another raffle in the next break, and there is like still the Xbox, I think, as a prizes. So there is a still prizes. If anybody leaves, just come and grab your name. If you don't leave on the next one, I'll just pick it up.
Awesome. Yeah, that's a good attempt. Yeah, thank you. Thank you for that. Any other thing that you can think of?
Vulnerability in third party.
Validity of the OTP, right? Like when you do an MFA, the basics thing is it is nothing but a second code that you want to give. The validity of that. It can't be that I'm looking at different 5 OTPs and I can submit anything. It has to be on the spot. Again, we're not trying to focus on existing vendors, but a concept of MFA itself. MFA could be anything. It could be a OTP that goes to your email. Because we haven't told it has to be a approved vendor like Okta or RSA. Right? Any questions on this, guys? Awesome. So now we sort of spoke about how to do threat modeling as a practice, right? We looked at getting one step ahead in terms of writing abuse stories once the product is going to go out, maybe in terms of the design phase itself, right, and whatnot. But how do we really automate it, right? Is there a way to be active, because we are still talking about agile methodology? It's not going to stop on one particular release. It's going to be frequent with multiple chains and whatnot, right? So that is where we have got 3 different products, and again there are tons, right? And nothing is a promotion, but these things really work at least for small teams and agile environments, right? So PyTM, I'm not sure if you guys have used PyTM. Have you heard about PyTM? You want to add to it? So PyTM is Python-based threat modeling, right? So what is it going to do? And it is as simple as writing a Python code, right? You don't need to be too comprehensive in terms of coding or creating functions. So it is available on GitHub, right? Once you download it, there is a default tm.py, right? Once you open that, there is a predefined structure as to calling the internet boundaries. Same thing. What we do, let's say if I want to go to draw.io to draw a threat model. Same thing, I'm just converting it to a code, right? Like what are my internet boundaries? What are my assets? What type of data are they going to store? Is there any criticality assigned to them, right? That's it. That's all you need to do. With a given template, all you need to do is change the keywords, to be honest, right? Default keywords could be data store. All you have to do is like really change in terms of Redis and whatnot. But what is going to happen is, given the criticality, the placement on the internet layers, right? PyTM has got inbuilt threads. And since it's open source, you are free to, add your own threads and whatnot, right? And it doesn't even stop there. If you want to create sequence diagrams, it's inbuilt. Just using one CLI command, the same Python file is going to create your sequence diagrams. Data flow diagrams, right? Again, you don't need to create a new one, right? So assume, coming back to the same agile threat modeling with multiple releases, you start once based on different releases, scope, you just keep on adding 1 line or 2 lines at a time. By the time the entire project is over, it's done, automated. That is why PyTM really helps, right? But since this is still more of a CLI version, right, and not just give one second. It's on. It's not connected. Just around. It's turning on, I guess. It's on.
It didn't charge that.
Hmm?
It didn't charge that time.
It was connected. I don't know.
Battery time. No, it's battery got.
Share his screen. He's joined his screen from.
Yeah,
I think he got disconnected from Zoom.
no, his laptop battery got. So it should be.
So got disconnected.
Slides.
It's bad. So now coming back to the next tool, right? Thread Dragon. So the only I wouldn't call it as a limitation though, but PyTM is only for people who are good with CLI. People are not used to that, who don't know zero Python. How do they still do it in terms of automation, right? That's why we have another tool called Thread Dragon. So it is available on Windows as an executable. And it is cross-platform as well, right? So this provides you with a drag and drop interface, similar to what Product.io does, right? You can create your all the components, data store, how they are connected over HTTPs and whatnot. Once you do that, you can click on each component and add different threads as a plus icon, right? So that is where it does the same thing, but more from a UI perspective. Right? And third is Fragile, right? So it is again an open source one, but this gets integrated as part of your IDE itself, right? So technically, to go back to the, everything is open source GitHub, right? You have all the default templates available to see how it really works, right? But PyTM and ThreadDragon is much more easy to use for anyone, even person who doesn't really understand what threat modeling is, only basics tried, also even concepts of that, they can really start using and perform threat model from day one. So now, any questions on that, guys? Right? Anything on the tools that we spoke about? Awesome. So we spoke about doing threat models. We spoke about abuse stories, getting ahead of the curve, right? We also spoke about how can we build threat models automated, right? Rather than worrying about me going to draw.io or using any other native tools to build different threat models, right? So now let's focus a bit more on different type of security controls, right? That we sort of implement. So do you guys know the difference between preventive, detective, and corrective controls? Can someone give an example? Anything that you would have read anywhere? So network security controls, right? What kind of controls are they? Let's say that's a WAF. What kind of control is it? You can set them to monitor mode. That is a feature of the product, but ideally those are preventive, right? You put WAF in place as an example to prevent something. You don't want anyone to, let's say, inject any malicious HTML code and whatnot, or XSS codes, right? Detect it. And what is the main purpose of preventive? Like, why do you want to do it? Why can't we just keep it in detective, right? Every company has got tons of tools. Why do you want to prevent? What kind of risk are we going to prevent?
Just me, but it's not you already
What's the risk that you see? Because we know these tools exist, we have read about those, we know it should be used. That is cool. But then, what kind of risk are we trying to prevent from a company perspective?
Well, the risk in detective is that you can really never know how much information they have or when they're in the network from an initial standpoint. So we use the preventative to even prevent them from getting to that.
That's how the controls work. I totally, on board with you. But what kind of risk? We spoke about different kind of risks from a company. Something to do with, as a simple example, would be availability of the application. It could be any kind of attack. It could be process scripting. It could be rate limiting prevention. But the main idea is still focusing on the availability of the application. That is a major risk. I want my products to be available to the customer. So that is the gap that I want to fill in your minds, right? Everyone knows every tools exist, but why is the question? Why in which use case is what we need to really think. I'm sure you can Google anything, everyone will say we have to do it, but why? What kind of risk are we trying to mitigate for the organization? So similarly, in detective, why do we really need detective controls?
So we can detect.
Sorry?
So we can detect.
They already went with preventive first, so they already want to prevent it before even detect.
Not everything we prepared is the one the issue of that's what it comes to.
Preventive controls are not working. We are trying to see.
This looks like a chat GPT answer, man. Because this doesn't work, that has to work. But again, let's think very logically from a security personnel, right?
If you don't want to break stuff, you want to be aware of it.
Okay. That is to make sure, again, from an availability perspective, any use case that you can think. Well, let's put it that way. Real world scenario, right? Every company that goes through, and we only put detective controls on that.
Find out the different ways that you attack.
That's a very broad case. Still, can we be more specific? Which every company still does it on a day-to-day basis. They can't do anything, but they can only have detective controls.
So in terms of like a physical security, you get to know like CCTV and all being put as a detective control so that a person carrying a gun or something like that. First, that is the first step in detecting, then just the preventing by stopping.
Okay, so that's one use case. Second very common is IP address logging, right? If a user logs in from a different IP, we don't prevent anyone. We still just do detection and certain notification. Did you log in from this IP? That I'm sure everyone would have get seen emails from Instagram and whatnot. Because we still want the service to be available, because we don't want to block anyone by default. Those kind of scenarios where we don't want to restrict anyone that we don't do this, we can only rely on detective. So that is where we come into picture as architects to really understand in a given use case, where should we really go for preventive, right? Today, let's say every company has got a set of customers. We know who's doing what. Why don't we just allow those and block everyone? We can't. Business still has to run for different use cases, and things can pop up at any given point of time, right? So that's why we need to be very much cautious as to when do we put preventive, corrective, and detective, right? Anything based on corrective. When does corrective even come up across? Forget about those keywords, forget this slide, right? When does corrective controls are being implemented at which cycle?
After the attack being taken.
Yeah, so it is comes at the last stage, right? Once something has been identified, then you have to take a corrective action against it. So this comes at the last stage. Obviously, patching, I'm sure quality scans and whatnot, those things come at the last stage, right? So that is the different type of controls that we have. Right? So again, maybe since again going back to Stride. So we spoke about spoofing, right? So we know okay, spoofing can exist. Let's say you're doing a threat model, you know spoofing can happen. But now it's time to act against it. So what are the controls that you would say? Let's say it's an e-commerce, simple application again, right? What kind of control would you want to put for spoofing? Spoofing means what? I can impersonate you, right? So putting a CSR token is not going to help against that. What's the common thing that everyone enforces? MFO. Right? Okay. How about tampering? How do we solve tampering? What does tampering mean?
Making changes to it.
Okay. So then that we understood. So how do we prevent it?
Certificates.
That is still going to be for confidentiality, not for integrity. Putting certificates or SSL or anything of that control, it's just going to put a tunnel on the data, not the data itself. You got my point? So the SSL is just between your browser and the server. So no one can sniff it. That's true. That is just a defensive again. It's not going to prevent it.
Like verifying the same information.
How do you do it? What's the keyword? We are security folks. Checksum hashes, right? So any data that you send before you compute the hash, right, and you make sure that the same hash that's there on the other side. That way, even a single word, a dot, anything's added, that will never be accepted. Make sense? Perfect. Now on reputation, what is reputation? So what control do we put? Log, sufficient log. Again, now that's what I believe every architect says, gives an action item to the team, have sufficient logging. That's it. And our job is over. But is that really right? We don't want to log everything. I don't care if memory goes 90%. That's from an availability perspective. I don't care. I still care, but every company has got money, man. Right? Every is on cloud. We will spin up 5 more servers. Having the necessary logging events is what makes it very important. We can't just go back and say, just log everything. Select star. That can't happen. It is very much specific. For my given application, I really understand. Let's say I'm Amazon. I'm worried about adding items to cart. That is where I want to make sure reputation cannot happen. So what are those API calls which are going to hit the cart? So those APIs, I want everything to be logged. Like 403, like anything critical for that. 200. Again, 200 combining with geolocation, right? Those sort of correlations what I want. For others, it's fine, right? So that is something that's where we come into picture. Our job is not to be a checklist that, okay, do this, and let's get out of the ticket. No, we have to be better at how we do it. Right? Information disclosure. Next one in stride. So what does that mean?
Giving access information.
Who's giving? Me, the user, or the application infrastructure, right? So again, what's the control? Again, very easy to decode from the keyword information disclosure. But what is the control that we? Data loss kind of example could be a stack trace. That is still information disclosure. DLP is not going to prevent anything. DLP can only work with, and again, it's not how it can work. Everything depends on how you configure it. But normally DLP is on the endpoints for specific type of strings. Let's say I don't want credit card information to go out irrespective. In a given way. That doesn't mean APIs can't access it, but SSH through SSH protocol should not be allowed, right? As an example. So those sort of correlation is what we put on DLP. So technically, we have to make sure that, again, it all depends on what kind of information disclosure it is. Information disclosure can also be of the case where I'm trying to get access to your data. That's also information disclosure, right? But then for that, we have a different type of control, like access control, right? You have to make sure that every time I'm trying to access an object or an API call, every time I'm being validated, rather than only on the first time, right? That's where most applications go wrong, right? DOS. I'm sure people will come back with rate limiting, but is there a better way? Can only putting all the burden on your external WAF is the right way? We should have rate limiting at different layers, because depending on the trust boundary, over the internet, we will have larger bandwidth. So WAV, Akamai, whatnot, right? We will go with, let's say, 50 requests per second as an example for a particular user. But now, at a given point of time, a user can't be accessing multiple APIs or same APIs multiple times. So once you get onto different trust boundary, you need to have API gateways now, which actually validates who the requester is. And that is where we architects can help them build it. Because I might be passing my session IDs and whatnot, some way to identify who the user is. But now I can't have the same 50 per second. I have to trim it down to 5, maybe 5% as an example, again, depending on the use case. Right? So that is where different rate limiting and different layers is what's important. Right? Elevation of privileges, what does that mean? Apart from the keywords, whatever it describes, any example that you can think of in real world?
Again, in terms of data centers, only authorized persons, first like fingerprints, biometric, and all the authorized persons can log in the data centers and not.
That is, we are still talking about preventive. I'm talking about a actual attack itself, right? As an example, where do we commonly see elevation of privileges? Have you seen remote code execution vulnerabilities in the market? And especially the ones which are exploitable over the internet or the network devices or anything like WordPress as an example, right? Those things are of higher severity because it doesn't matter who the person is as long as your payload is crafted in the right way. I'm trying to be very generic, but as an example, right? That is why we see so many attacks. People or hackers or script kiddies, they don't even need to understand what the payload is. As long as they see a verified payload available with a 9+ severity over the internet, that's all. Right? Main idea is to escalate the privileges, again, either to maintain access or to export sensitive information from the server. Right? So did we make some progress in terms of understanding as to why a control should be used, which risk are we trying to prevent, rather than going with standard response from the internet, right? So every company is quite different. Every organization is very different. We can't have a generic answer for everything. Hence, we still have all the vulnerabilities in the market today. We have all the developers and same set of team for every company to protect them. But that is the reason, because we don't customize it for each request, understand why for this. We don't have that why answer. We have been told this is what has to be done from the top management, follow this, and this not. That is where things go wrong. And the last thing which I would want to focus a bit is our communication to the team. All the hard work has been done. You did an awesome threat modeling. Then after that, you also have put automations to do threat modeling, right? You have given the correct severity and everything has been done. But do you think we communicate it in a good way to the teams? Let's say a simple example is there's an API which doesn't have SSL in place or HTTPS in place. What do we say? Lack of TLS, finding has been raised, and high, medium, whatnot. That's it. Mitigation is, put a HTTPS certificate. That's it. But do you think that the team or the developer, they really understand? Apart from the fact that, okay, it has to be done, we see every day on the internet. We really don't emphasize as to who can do it, where he can do it, and if that really happens, what is the impact, right? So this is something, I would say people should actually search AWS Threat Grammar. That's an online GitHub repository available online, right? So this is how we have to sort of write. Let's say who the attacker is. It is quite similar to the abuse stories, but abuse stories don't talk about the mitigation, right? And which assets, right? So this is how, as an example, right? Now, if you can read this, if it is clear to all of you guys as to an attacker with compromised credentials can initiate unauthorized purchases using the given feature, leading to fraudulent transactions, negatively impacting the integrity of user accounts. Now, anyone who reads this within the organization, I'm sure they can understand, rather than the one title that we gently say, lack of this. But we don't go ahead because they don't know why should I do it? For whom, which asset should I do it? go back to the ticket and take a look at it, right? So yeah. So that's what I had from my side. Anything if I might have bored you guys, let me know. I can bore you guys again. I'll call in Prashant for the next module.
Right. We'll go through some of the real world examples of different kind of threat models we'll be doing. So first example is of an e-commerce application. I'm pretty sure like most of you might be ordering your stuff through Amazon or Kohl's or Macy's. So in that way, like you are already a user of one of the applications and you can perceive some of the threats in a better way. This is an old, three-tier architecture of a traditional application. How many of you like understand this, like how this works? Like, what is the three-tier over here? Why is it called three-tier architecture? Yeah. So basically, you have a browser which is like interacting with an app server, and then app server is interacting with database. So I mean, earlier there used to be a web server and then app server differently. Majorly, people used to say that as three-tier, but largely in the modern day architectures, we have like one web server or app servers, and we have a front-facing load balancer. So majorly like either the load balancer or the load balancer plus the web server will be in the internet zone, and the database is on the internal zone, which is not facing to the internet. Okay. By any chance, does anybody know like what is this internet zone was called earlier in the traditional? Let them tell. So in that, DMZ, yeah. So basically, in the old age, when we had our own data centers at that time, this particular zone was basically called a demilitarized zone. Okay, I mean, it is kind of like say nobody can go there. I mean, it is like sacred to be there. Make sure that like we have all the security tools in place like that. But but in the modern day, I mean, like now with like cloud and like we have the architecture has kind of changed. We'll go through that as well. But in this particular case, let's try to do the threat model. I mean, see, basically the issue with threat model is that it's not never enough. Okay. So typically in a new project, you start with a deployment diagram and then slowly you get into the application feature module like that. So that's what we're trying to cover in this particular training, that we'll start with the larger application and then go to the smaller minor details as such. Okay. Now, a fundamental of threat modeling is assets. How do you identify your asset? Okay. I mean, you can only protect what you know. I mean, so what you know is basically your asset. If I know that my house is an asset, I will have a boundary wall. I will make sure that I have CCTV cameras and everything. In that way, I try to protect that. So in this particular case, what are all our assets? Database, yes. Server, yes. Browser as well, the laptop as well. So as a customer, it is my responsibility to make sure that my laptop is safe. Okay. I mean, if I'm buying something from Amazon, Amazon doesn't really care if your laptop is safe or not. I mean, it is your responsibility. Whatever happens in your laptop is your responsibility. Okay. So in a typical threat modeling scenarios, we don't really think about the endpoint security that much. I mean, there can be exceptions. I mean, if it's a corporate laptop, definitely we'll have to see. But from a customer angle in an e-commerce application, we don't really like think about that. However, once the data leaves the browser, it goes to server. Okay. So at that time, like what kind of stride attacks can be possible? Stride controls might be applicable. I mean, spoofing, tampering, like those things can be there. So largely, like what is the threat over here? Like man in the middle attack can be a threat here. And then what is the control we can do as an e-commerce application provider? What is the control we can put? HTTPS. Okay. And then if that is not there, I mean, for example, you are seeing and doing a threat modeling of an application and you say that, okay, are you using HTTPS here? And if they say no, in that case, that becomes a vulnerability. Okay. That is where, like, say, I mean, typically you create a Jira ticket and you ask your engineering team to work on it and fix the issue. Okay. So the sequence here is that, I mean, you try to identify that asset. What all things can go wrong basically becomes your threat. And then if you already have something in place to mitigate that, that becomes a control. And then if you don't have a control, that becomes a vulnerability. And that's where like you need to work with the engineering team to fix that. Okay. In this particular case, like say the first thing was we identified that, okay, from browser to server, we should definitely have a HTTPS in place. Okay. Now at server, what can happen? Denial of service can happen. Okay. What else? What do you have on server? Application. Right. So data is there on the database. So your application code is running on the server. Okay. So then, I mean, what all application level vulnerabilities are there? That becomes important. So all these OWASP top 10, those kind of threats will be applicable there. Okay. At the high level, I mean, at the initial deployment layer level, predominantly the network layer attacks will be applicable. But once we start doing the application level threat modeling, the application level threats will be more applicable. Okay. So here, I mean, what worse can happen? Like say, if a server is compromised. I mean, the code can be leaked, and then from this server, somebody can actually try to do a lateral movement and get data from the database. Okay, so that's where how can that be done? SQL injection. I mean, yeah, again, predominantly application level attack. But in this case, like for example, if the server itself is compromised, he's sitting in the server. How can he find out about the database? How can he get into database? Yeah. But again, you need the credentials to connect to the database. So the application is compromised. At that time, I mean, you need to find out that how the application is fetching the connection strings. Okay. So the first thing what an attacker does is that he will try to find out the connection string and see if the credentials are there anywhere. I mean, if you're taking it from the environment variable, or if it is like if it's in the configuration file. So he'll try to identify that and then subsequently connect to the database. Okay. So these are some of the like things what attacker would try to do. Again, I mean, at the layer like from app server to database, you should have the SSL enabled. And that's where like we try to keep the database in the internet zone so that internal zone so that it's not directly exposed on the internet as such. Okay. These are some of the like bare bone security practices which we were followed when we had a typical data center. And largely the tools like IDS, IPS would sit in the DMZ zone. I mean, we would have an internal firewall as well, but then largely the security controls will be there in the DMZ zone where we try to do the initial threat mapping. Okay. Then now come to the cloud world. Okay. So this, I've taken a photograph of a WordPress 3-tier. Okay. So typically, I mean, it's a little bit more complex now when they deploy the application in cloud. So you might have the entry load balancer, and then you have a WAF in place. I mean, if you typically like you can enable a WAF from AWS or the GCP, whichever you're using, and then you have an internet gateway through that. Like you have the internet subnet. So you can all keep your app servers in the internet facing zone, public subnet basically, and then internal network. If you are using the hosted, I mean, database, in that case, like, I mean, the IAM rules can be used and through that, like, database access can be given. So the threat landscape here, then, like, say, you have application layer attack. And then, like, say, if you have a cloud misconfiguration layer attack over here, for example, you are using a S3 bucket. However, that S3 bucket has public write access. Okay. So that is, I mean, as a developer, probably I might even not know that, I mean, something like that can be there. SRE team can do a mistake and give that as a write access. So that's where, like, the threat modeling level, you can point out to the team, which team, I mean, might be responsible for correcting what. At the engineering level, I mean, the engineers or developers' responsibility is to write secure code. At the SRE level, their responsibility is to maintain and give a good secure platform to the engineering team as such. Okay. Now getting into the application level modules. So typically in an e-commerce application, how does the workflow happens? For example, I open Coles.com. and maybe like I have an account, I log into the account. That is basically the account management. I mean, or like say I create an account, that is account management module. Then I go to search and I search like say blue jeans. So it gives you a whole catalog of product. So that's basically a catalog module. Okay. And then like I will select one like say Levi's jeans and put that into my cart. Again, whatever happens in that cart is a different module. And then I press on checkout using the credit card or like PayPal. I pay for the item, and eventually the checkout happens. Okay. So and then like once the order is placed on in the back end, the order management team will work on that, and the product will be delivered to me as such. So these are some of the modules in the application which will help us like doing the whole transaction from beginning to the end. Okay. In the traditional world, like in the monolithic world, I mean, probably these were like a single application. But in the present day architecture, I mean, each one of them can probably be a microservice. Okay, so account management can be a totally different microservice. Similarly, search might be coming up from a different service as such. I mean, InfoSec Institute has a nice write-up on OWASP top 10 to stride mapping. Basically, like when you do threat modeling, a lot of engineers who come from pen testing background, we try to think predominantly from a OWASP top 10 vulnerability standpoint. So, like having a mapping from, let's say, stride to OWASP top 10 is kind of helpful, where you can tell them that, okay, this will be causing you like spoofing. This can be possibly like a vulnerability can be lead to tampering like that. So this is something, I mean, interesting blog you can actually refer to. From my technical, I mean, interest, I mean, like experience, whatever I had, I majorly like from the OWASP ASVS project, I kind of feel that, I mean, these are some of the major controls. Using that control in mind, when we do threat modeling, a large part of like threats can be actually covered. Okay. Like I mean, like say authentication. I mean, it can be user authentication as well as like say service to service authentication, machine to machine authentication, like that. So using this control, probably I mean, large part of like security, I mean, threat modeling can be done. So I try to use these as my baseline to do the threat modeling. So let's now do a threat modeling of e-commerce application as a whole. Okay. So now authentication. I mean, like say, I mean, an engineering team comes to you and say that, okay, now we are planning to build an e-commerce application. Help us out. And you, in fact, we have created. I mean, we have this. We have created a product spec and tech spec as well. As part of the workshop, we were thinking that we will give the product spec and like see if I mean, team can do that, but I think we'll go with the instructor-driven threat modeling here. So understanding that, okay, in a e-commerce application, I mean, majorly like where authentication coming into picture, basically for the customers, right? How do you like authenticate customers? Username, password, or MFA, okay, and what more? There are social logins also available, right? Yeah. So yeah, OAuth flows. So then what is the threat here, or like a recommendation here? So like say for example, in case of authentication, I mean we need to make sure that user cannot like access something without authentication, right? So the threat here is the I mean unauthenticated user. But in an e-commerce application, what can be a possible I mean risk of unauthenticated user? I mean if I see somebody else's data, that's one thing. However, if I buy something as an unauthenticated user? Yes, you can buy as a guest, right? So the risk is a different kind of thing from an unauthentication purpose here. But for authentication specifically, what all recommendations you will do? Imagine that first thing we are going is with the user ID password. So what recommendations you would give? Password strength, yes. Rate limit. What will like rate limiting prevent from? Brute force attack, credentials. Yeah. So I mean, in this particular case, your asset is your user ID password. Now, what kind of controls you need to put around that? I mean, you can derive it through stride. Okay. So then the other question what they might ask is like, how do I store my password? I mean, there is I mean, if you go with a 3-tier architecture, the password is coming from client side to server side. So we need some I mean controls over there, and then from server to database it is coming. So what controls we need to have over there? Okay. So at the browser to server side, we told that okay, there is HTTPS definitely required. We need to have rate limiting to make sure that there is no like credential stuffing attacks. If you have a good password policy, it makes the brute force difficult. Okay. And then it comes to server, and then you're storing it. Now, what is the right way to store password? I mean, do you think it's a sensitive information? Should anybody else other than the user have access to that information? No. So we need to make sure that when we are storing the data in the database, the password should be in a secured format. Now, what is the secure format here? What do you recommend here? Hashing, will only hashing suffice? Yes, salted hashing, keyed hashing, and then use I mean multiple iteration like say bcrypt or pvkdf2 to make the cracking difficult. Okay, so those are some of the things like understanding the asset in this particular case and giving the recommendations comes into picture, and that's how like the flow of threat modeling kind of happens. Okay, similarly, I mean authorization. Now, I mean from a customer standpoint, where can authorization checks fail? I mean, where authorization becomes important? Access, like there are like two things here. Like I mean, lateral access and the horizontal access. Lateral access, like say I as a Prashant login, or like say I as a Prashant should not be able to see size data. I mean, we both are customer of the e-commerce application. However, I as a Prashant, if I'm able to see everybody's data as an admin, then that becomes a vertical escalation. So then again, having the checks over there. Okay. So how do you do authorization checks? I mean, you would have to ask the engineering team and understand the logic and then correspondingly give the recommendations. Okay. Data security. Now, in the whole customer journey, what are the sensitive information we are seeing? Credit card information is there. PII is the personal information, and then the customer password. Okay. So each 3 different categories are there. Now we have to have preventive mechanism or like the safeguarding mechanism for these 3 assets. Now these becomes our asset. Okay. So password we already discussed that okay, we should be making sure that it is stored in the hash format. I mean the salted hash format. PII information, like say my name, my address. What do you recommend for that? Huh? Typically in e-commerce, I mean, we don't encrypt. PII, we don't encrypt, right? I mean, that's an ideally good practice, but it, I mean, the places where it has to be retrieved, like say order information or for the support purposes, it has to be retrieved at multiple places. So in that way, PII kind of like is not like really encrypted, I would say. I mean, we can just make sure that, okay, this data, I mean, even though it is not encrypted, is only accessible to certain people. Not everybody can do a select on the table query and like extract that. Okay. Then comes credit card information. Okay. Now, what do you recommend that? Masking or basically like tokenization. The tokenization is predominantly used for storing the credit card. Okay. So, I mean, the point what you're trying to make here is that understand your asset, basically what you are trying to protect. In this particular case, data is your asset, and what kind of data, accordingly, like you can move from one data to another. Okay. Audit trails. So, I mean, we cannot say like put in audit trails for everything. I mean, you need to understand the sensitive state changes. Okay. So, I logged in. I mean, tomorrow I can like say that okay, no, I never logged in. I mean, this particular transaction was not done from me. So we need to have a audit trail for the login purpose. Similarly, like say I purchased this item. So at what point of time, when, how that information should be logged in. So understanding again the sensitive information and then giving them the recommendation that for these sensitive transactions, we need to have an audit login. Okay. Again, this is majorly like say at the design and I would say requirement phase, we are doing this activity. I mean, the coding, I mean, we are assuming here that the coding has not really started, and that's where like we are trying to do this one by one. Then cryptography requirements. In the sensitive data, whatever we discussed, where do you think cryptography would be needed? Password. We already spoke about password, that yes, a password needs to be stored in a sorted hash format. So that is there. Then the lot of time engineering team would say that we don't know the right algorithms to use. Okay. So we as a security engineers, then we need to know that, okay, do not use MD5, do not use SHA-1. Okay. So like that. So that information, I mean, it is expected. I mean, I would say in a technically savvy engineering teams, the engineering might know. But a lot of times they don't understand this cryptography algorithm, and it is good that as a security engineer, we know them and we recommend them the right practices. Okay. Similarly, credit card. I mean, so credit card, I mean, hash would have worked here or encryption would have is better. Yeah, because hashing is basically one way. I mean, when you don't require the data back, we would recommend hashing. But there can be places or time when we want to see the credit card or like get the actual credit card information. At those times, like encryption or tokenization will be better. Okay. All right. Then I would come to third party later. Information leakage. Lot of times, like the developers or engineers log the sensitive information, and those end up in the logs. There has been instances where, I mean, large organizations, somebody actually logged a password, and then you get an email saying that, okay, please change your password like that. So that also, I mean, at the design level, you can recommend that, okay, these are some of the data you should not be logging. I mean, for example, credit card should not ever be logged, or password, they should not be logged. Do not use get method for doing the transactions, because get method that the URL gets logged in the HTTP logs like that. Okay. Going on to third-party access. So for in this particular e-commerce applications, you might have ads, okay, or like say trackers. So in that way, you are including a lot of third-party JavaScripts on your website. One fine day, they can go rogue and your application becomes vulnerable for that. So that again, I mean, you need to keep an eye on that. Okay, that's also a threat for us. What mitigations you need to put in? I mean, PCI has come up with some of the recommendations. Similarly, like say for the customer service, you are like having a like say Salesforce application is being used, and you share the order information in that database. Again, like if like your application is secure, I mean you have like protections there, but the Salesforce integration what you have is vulnerable in some way, then again your customer data becomes accessible. So that's another thing. When you do the threat modeling, you need to understand that if you have, I mean, apart from the code what you are writing, what all other third-party integrations that you are doing, and how that can, I mean, if something can go wrong, then what is the data that is at disposal? Okay. And lastly, that's a major one, compliance. So the application what you are doing threat modeling, you need to understand the compliance aspect. I mean, what is it like? We will be have to go through the regulatory or the compliance as such. So for e-commerce, I know like PCI compliance, we definitely need to be compliant about. There are regulations like say GDPR, CCPA that we need to be compliant about. Largely, I mean, people assume that some of these will the GRC team will come and give us a requirement and we should be good. But converting that GRC control requirement to a technical controls and the technical implementation, security engineers might have to think. For example, PCI recommendation says that network segmentation should be there. I mean, the segment which is like dealing with the credit card information, network segmentation should be there. Now, a GRC team person cannot tell you how to do that. Largely, I mean, as a security engineers, we might have to work with the SRE team to get that implemented. Okay. Similarly, like say the third party, the data what you are sharing with third party. So there are like data deletion requirements for GDPR and CCPA. So for example, like say I am shopping at your website I delete my account and I say that I delete my details from the third party as well. So there should be some kind of service which actually goes and tells the third parties as well that please delete the customer who is no longer wants to doing business with us. Okay. So those kind of like understanding the compliance requirement also becomes important for a security engineer. I mean, the controls might come from GRCT.
Everybody's gonna get around photo. You guys speak the group photo for like 5 minutes, and if it's okay to stop it, if you decide that you want to keep on, that's fine. Speaking about it's gonna be a group photo. 2-3 minutes, things like that.
I mean, if you want to go, we can stop this presentation. If you are enjoying it, then maybe we'll continue.
No, everything will continue after that, right?
Yeah, yeah, yeah.
Over, so
sure.
Sorry about it. Just saying. It's okay. Like you're not going to miss the world, so probably
okay. All right. All right. Yeah. So, so again, understanding the compliance requirement for a security engineer also becomes very important. And lastly, again, the engineering teams might not know about these controls. So having a partnership with GRC team again and letting them know that okay, there is a new initiative coming up, which might have a potential compliance. Controls to be put in, get their feedback, and then give the recommendations to improve. Okay. All right. So this is how like a bare bone threat modeling I kind of do on my practice. I'll hand over to Sai, who will take us to the next.
Thanks, Prashant. So yeah, so I think Ashwin and Prashant did walk us through the tidbits of the frameworks for threat modeling and also took an example of e-commerce and showed what are some of the components that you would look at like as an example, right? So what we are going to do is we are going to take another example. It's kind of an extension to an e-commerce application. Let's say there is a new module that your organization is coming up with, right? So, and before we jump in, right, we'll do it in like this next section is going to be like more interactive. So there's a lot of you'll have to jump in and tell what can go wrong, what are the best things that you can do. Okay. And just to give you some context, right? Every time it's the ideal situation to do threat modeling is way before coding begins, right? But not very often, right? That doesn't happen, right? You like I have been in a situation where somebody pulls me up and say, "Hey, we are building this," and okay, can you share the document? There is no documentation. There is no detailed user stories. The architecture diagram is half baked because they're still building it because we are in an agile world, right? And along with that, right? It becomes really difficult, but you have to work with what you have, right? What you do is we have to do rapid threat modeling, what Ashwin is talking about, right? So how do we go about it? Like, do you have a framework? Like we have Stride and everything. And we also talked about abuser stories for the stories that we have. I think they are great places and frameworks that we can leverage. So we'll do something similar. We are going to take an example of a different module that is going to be a gift card. Let's say your organization is introducing a gift card module. Like for an e-commerce, it's a very, or not just e-commerce, for all these different like DoorDash or Uber Eats, everybody has gift cards today because that's a great place to gift people. So we are going to take a look at that. And as you can see, this is the flow that we'll be following. Okay. So we are going to look at the components. We are going to look at each of this in detail, what it means. And then we'll look at the diagram. And then probably you can come up with some of the potential threats, what can go wrong, right? And while you're looking at the stories, and I'll walk through, think about what can go wrong. That's the only thing you have to think, right? You can apply all the Stride and everything behind this, but you are doing a rapid threat modeling. You might have to jump on a call with the engineering because you have limited time. The speed is of essence here. Okay, so we'll walk through these stories. So if you look at the components, we have the gift card purchase flow. You add a gift card, okay, you can add it and check out, where you can probably send it to the destination. Let's say I want to send it to Srajan. Okay, I add his email, first name, right, amount, and then add to cart and then check out from there. So then Srajan is going to read in this, right? he's going to read in this. There is going to be an API for that. Then there is going to be a management system where I can, like Sajal can look that I had $100. I used $50 on this product. History of the gift card that I had. Along with that, you would also have balance checker. Like, there is going to be an API wherein you can just add your gift card number and see what balance it has, right? So, and if you, there are some gift cards where you can customize. Like, for example, this can, if you're sending a physical gift card, they can order digital, but you also get a physical card, or even the digital will have the photo or customization with already existing themes. So we'll walk through that. And other would be reporting and analytics for the organization to see how many gift cards were being sold and how many are actually using, and etc. for various marketing and other details. So moving forward, right? So user journey, like we talked, gift card purchases, like navigate, selects the particular gift card, and they would choose a design option. Like, this is what we would get from a developer, right? Similarly, the redemption process. They'll add, checkout, and system validates the code, apply, balance. Like, it's just the journey and gift card management thing. Now, if you look at this, what are some of the things that can go wrong? Like, just think about that. This is a gift card, right? There is a number. Okay, there are different APIs for balance checks, adding gift cards, redeeming it. Okay, so what can go wrong? By whom? Okay, so attacker is attacking.
And if the amount can be stored in the database, it was given.
Okay, so you're telling when I'm redeeming it. So redeeming is an API, right? So I get an email, I click on it, I have to log in, and then that API with the card detail will go, and it'll say that this is the balance. So you're saying that we can tamper with that.
When I'm sending the other person, while the data is I can change the
parameter temp.
Yeah. So, but I'm the sender. I would have to tamper it myself, right? Unless man in the middle attack somewhere, somebody is spoofing, like if you're in cafe. Okay, yes. So man in the middle attack. Okay. Yeah, definitely. If somebody is spoofing, yeah, and they can even change the recipient to themselves, right? So, okay, that's one. What else?
while fetching the balance. Unauthorized data.
Oh yeah. Like if there is no validation, authorization, or probably SQL injection, right? So server side request forgery, etc. All those typical AppSec vulnerabilities would be definitely active because this is an entry point. There is an API. There are going to be body parameters that you can tamper and test against, right? So anything else? Anyone? Anything that this is the diagram, right? So this is the user. There's the API gateway. There is a checkout service, right? So you add, like on the UI, you add the gift card, reading the gift card, look at your transaction, and then eventually this is the service, right? Card design. There is a card design which will fetch the themes from an existing S3 bucket. This is a very hypothetical situation, just so that we understand. There is a S3 bucket where the designs are stored, and you get to select. And what happens is you can select, and then the purchase service call, and you'll have your own DB. And here, in this case, the gift card itself is managed by a vendor. Okay, typically, if you look at e-commerce, right, there are vendors who are very specifically dealing with gift cards. So you work with them. So let's say somebody added a card and it went the purchases. So there is going to be an API call to the gift card vendor. They'll give the gift card and they'll themselves send it to the recipient. Okay. So apart from that, there is this management API for reporting. So anything else that you think can go wrong here? There is an S3 bucket. There is a gift card vendor that we are integrating with. What are other things that you think can happen? Like we are doing rapid threat modeling. So you're on a call and this is what you have, right? So there are some things that is being told. But if you see anybody wants to say anything? right? So first thing is we are working with a different vendor here, right? So you will have to make sure that there are SOWs signed with them. If they have any pen testing reports, you can review them. If there are any vulnerabilities, making sure how we are communicating with vendor is also a thing, right? If they are exposing APIs, where are the API keys being stored on our end? How are we communicating? Is it all HTTPS? Is there a pre-configured secure backend channel where everything is configured, right? So we'll talk more, but otherwise there is also a S3 bucket, right? Is it open? Is it open, right? So that those so during threat modeling, it's all about asking all questions, right? For the given context. Like if you look at this, the next time you might be looking at something else, like maybe a password reset flow is changing, right? So you look at the components and think S3 bucket, what can go wrong? What kind of permissions are set? Is it an open bucket? And can somebody tamper with the designs there? Can somebody add a design which that shouldn't happen, right? Likewise, we'll talk more. I think, yeah. So let's move on and see potential threats, right? Yeah. Yeah. So one of the major things, because we're talking about gift card, is brute forcing. Like I don't want to buy gift card, but I would like to brute force that. There is a balance check API. There is a redemption API, right? I can try to use the balance check API and try all these alphanumeric characters, or even if it's numeric, and enumerate that. And this is a very relevant problem that we see with the evolving situation of bot attacks. And so like Ashwin did mention that everywhere we talk about rate limiting, and it's Akamai or the CDN that you have, Cloudflare, right? So depending only on that becomes really challenging. And the idea is to implement rate limiting in layers. So can something be done at the application level? Let's say there's a gift card and somebody is brute forcing for n number of times. Now you have that insight. What do you do? Right? We can lock it for some time, or if you're seeing this pattern for a while now for fraud, somebody has a gift card but somebody else is redeeming it somewhere, and if you just look at some of the underground sites, right, you will see that all these gift cards are being sold. Like it's $100 gift card, they'll sell you to $50. And this is really like a big problem for all the e-commerce. Like if the site is so well that you'll have to just select which vendor you want. You want Walmart or anything, any other DoorDash or anything, right? So you'll have to pick and they'll have that. So this is all happening. And in fact, this is my personal experience. I did go to Walgreens to buy a Amazon gift card, a physical one. So I wanted to gift it to someone, and they wanted it to open it and then activate it or just do something. I told them, you just activate it and I'll give it, because they wanted to open the pack. It was a nice fancy pack, but they didn't. I didn't buy it. End up buying that. That was because they wanted to. What they told us, we have had problems where the gift card is already being used. So this is my own personal experience that I didn't end up buying. Then I sent them a digital card. So, but this is a very relevant problem, and I think there are different ways you can deal with that. But like I said, this is both different. If there are two different APIs, you would have to implement rate limiting there, or you can also use CAPTCHA or any way where you can not automate those. But now the bots are getting so sophisticated that they are very slow even in attempting the check. So that those two. Then we went back to the S3 bucket, right? So if you look at the design, right, you get an option to select the design. And let's say you are like I go to gift card, I have ecommerce.com, I slash gift card, and then question mark, I select the design. So I would get something like design is equal to AWS S3 bucket slash image. Now, if I change the image, it will be image 2. But you see in the URL, I have another URL which is actually fetching the image from the S3 bucket. Now, what can go wrong here? Any thought? So, of course, we talked about the storage bucket being open and everything. That's definitely, you'll have to put in proper IAM policies. But what else can go wrong? Very good. That's exactly what can happen. So, this is actually a actual use case that if you look at Capital One breach, they had something similar for a credit card, you could change the skins. You go and select the skin that you want on your credit card. Not gift card, this is a different one, capital and bridge. They had exactly the same scenario. When you select on the skin, you would see that there is a link to, I mean, the URL would have a link to the image, which is hosted on the S3 bucket. And now what the bad actor did was, rather than the S3 bucket, they pulled some other image of cats from Google or anywhere. So that indicated that you could actually upload anything. And what eventually they did was the hacker, I think I don't recollect the name, but they used a metadata endpoint of AWS. So all this cloud services, right? They have this metadata endpoint, which is which is 160 to 169 dot. Yeah, it's common, and depending on how your app, what permissions it is running, right? So what you can do, you have a specific path in the metadata endpoint. When you go there, it will give you the the credentials, the AWS keys. And she was able to get that. And from that point on, right, she was able to download everything. Yeah. So something similar. So whenever you see, so every context is going to be different. So threat modeling, like I said, right, it's rapid threat modeling. So you'll have to jump and talk about that. And you ask questions like, how is the S3 configured? And any questions that you have. And what else? Yeah, of course, phishing and social engineering, because we are talking about gift cards. That's a lucrative, target for all the bad actors. And you will always see, and what you can do about it, right? You can only educate your customers about how scams can happen. And this is only few threats. Like if you keep talking about everyone, one of the things is that you have to understand that this is just a very specific module, which is an extension of a huge e-commerce application, right? There is no details about authentication given here. So those are the questions again would come in. So when we do rapid threat modeling, it's always good to go with kind of asking all these questions. So something like, like for example, this would be like a typical thing that you go like, how is authentication? So it is always assumed that we will leverage the e-commerce authentication, right? So that is great, and that should happen because the account team will have their own account. As a login, I'll get a session, logged in session, and from that point, any feature that I use will leverage that until I sign out. Okay, and like it looks like very obvious, but I have in my consulting days, I have actually come across a place where there was an application and they had a feature, and when you log in, you'll get a session ID. But for that particular feature, they didn't leverage the session. They had their own token that they generate, and anytime you access that feature, that was being leveraged. And when I sign out, only the session would get invalid, but not the token. So they had done it for some reason. It was a legacy system, but we recommended that leverage this. So those do happen. So asking them is okay. They might know, they might not know. And then secrets, like we talked about the vendor being integrated, right? So if you have a pre-configured secure backend channel using an API, right? API key. So where is this API key being stored? Ask them. Is it hard-coded in the code, config file, or the best way is to use a vault with whatever infrastructure you have. Likewise, authorization, making sure that I'm not able to see somebody else's data. And again, data, right? How do we store a credit gift card? And in this case, the vendor is managing everything, but to certain the gift card management API, right? You would want some local data to have, and how are you going to store that? You can use hashing if you don't want to even store the the gift card number. And again, audit. This is for non-repudiation, right? Making sure that who is accessing what gift card, where it was being sent, who is redeeming it. That would make sure that you have a trail for any investigation or so like I said, if you want to use hashing, use algorithms like PBKDF to pcrypt. But again, it depends on the use case, what your organization would have. And last but not the least, right? One of the important things when you do threat modeling is giving actionable items to the engineering team. because it's very easy to come up with a list of threats and mitigation steps and dump on them, because they have their own challenges and they are up against their own timelines and deliverables. So it becomes more easier for them if you give very actionable items. Say, you know what, we want rate limiting so that nobody can brute force gift cards. Okay, first thing is you can use CDN or work with them to see if you can implement a logic to block after, say, 10 items on a gift card, on a particular gift card, right? So you work with them. So enforcing rate limiting, allow listing the vendor and your server to server call, allow listing the IP addresses, then making sure you have leverage the existing authentication, then securing the API keys. What else? Like, we talked about data use, making sure that HTTPS is used, and so on and so forth. So with this, right, now we had quite some time now talking about threat modeling. One thing you must have observed is that there is a lot of data involved, that lot of documentation review that you have to do, right? So as much as threat modeling sounds cool, like it's really manual and laborious, and you have to go through all these documentation stories so that you understand and provide your inputs from a security standpoint. So now than ever, with Agile, with Copilot coming into picture, the throughput of developers and the product features have increased like 10x. How do you catch up with them, right? By the time you finish your threat model and come up, there is new release that is coming up. How do you catch up, right? So, and we saw some of the automation that Ashwin is talking about, PyTM, Threat Dragon, and that really helps. But with the advent of Gen AI, right, there can be some things that can be leveraged, right? So I'm going to just quickly show something. Right, we saw all these things, right? We saw a diagram. Let me go back here. So we saw this diagram, and what we are going to do, I'm just going to show a demo.
Okay. Hey, Sai, before you switch, can I ask a
Sure.
question? So, just trying to think, like, is there a good framework for this? Because what I worry about with this is that the quality of the threat model is subjective to the knowledge and experience of the product security analyst.
Yeah. So there is actually before, right? So Ashwin talked about framework like Stride, leveraging that. So that's definitely, we have a bunch of frameworks that you can leverage. And if you follow that, that's really a standard process, asking questions depending on the context and providing.
What do you use, Stride?
It is, but it's very popular. Yeah. So definitely, so Stride is very popular. I mean, the people that at least I have been working with, most of them use Stride. There are others, one like Pasta, Dread, but Stride has been very popular, I would say. But I agree, like I said, right, it's a very laborious thing. Like, you have to go and talk to people, and not everybody would want to even, or not have time for security for you. But I think threat modeling is mostly building relations, with teams so that they communicate as well, and you are involved as part of that process.
So what if you did something in the middle, which is you went back to your architecture diagram? So what you have is, you have services, you have data flows, and if you have business logic. There's three things that are going.
Yeah.
And essentially, what you're trying to figure out is what are the common weaknesses in those, and what are the threats to those. Right. So again, without going into a big Stride model, like if you were able to do that, you might be able to do it more objectively. Because how do you know that you hit all the right points in the?
Oh yeah, that's what, right? So if you have time and everything, you can go back and do a thorough. But during a rapid threat modeling, speed is of essence. Like, you don't have time; they're already there. Right? You can give this inputs by looking at this, right? Or I would say, if you have a team, you take all this, you give them, then go back and do your thing. If you find something else, you can. But what I'm saying is that within that point, right, that 1 hour, if you can give them some actionable items that they can actually start working on, it's a head start for them as well. and then you can go back and do all this.
Fair enough. So
Yeah.
it's a time constraint.
Yes, of course. Right. If you have all the time, you can also put all the trust boundaries. Like, if you look at typical threat modeling, you would put in a threat boundary. How is the permissions being changing? For example, from if you have, let's say, consider if you have PCI related component here, right? How the trust boundary changes. So once the request or data comes here, so it's going to change there. What are the controls there? Is there network segmentation for PCI related stuff? Right? So definitely, but like just before this, right? So there were two, Prashant and Ashwin, they gave some context about the frameworks and everything. So yeah, no worries.
I think just to add, consider all the cases have been taken care of. The way to validate is like flight test cases. Okay. And then you can go back and see like how did we do. That's like the fourth component.
But sometimes STIM isn't valid, like what feature isn't available or defined something, and the company doesn't have a well documented points.
I mean, that's when questions, asking a lot of questions when you are reviewing this and getting answers to those.
So
it would take much time, right?
Which one?
If the team isn't well, like
The security team or the engineering team? Okay, so mostly engineering team will know because they're developing it, right? So because they will know because they are already developing it, so they will have it. But what you're saying is that they have started building, they are not clear about the requirements.
they are ready to know, and whatever failure isn't available.
Oh, okay.
That the knowledge isn't transferred well enough for the future developers.
Right. And even APIs might get deprecated. There might be new APIs developed. So definitely that's a challenge. But like I said, if you're threat modeling a component, it's a new one. But if you're threat modeling an existing one, then you'll have time, right? And you'll have to go and make sure to understand the unknowns. And if they don't know, you'll have to talk, or they should figure it out. They'll have to figure it out otherwise. And then you can do it. But this is for new features. With the limited time, what you're going to do, right? So you give them actionable items so that they can work on that. And then you go back and do your due diligence. If you have anything else to add, you can definitely come back and let them know. So,
sorry, another question.
Yeah.
So this is a new feature that you are threat modeling.
Yes.
In the context of a pre-existing application.
Yeah.
Right. So how do you threat model it considering the bigger scope? I know you're threat modeling this particular feature, but do you also consider the bigger application while you are threat modeling this new feature? Do you see the risks that the other application can pose to this, or this application can pose to the overall e-commerce app?
Yeah, definitely. Like to certain extent, we do. Like I said, right, in the diagram, there is no specific anything related to authentication. So this is an extension of the larger app. So we'll make sure that they are using the extension or authentication for that. And at times, this is a very simple diagram, but there are multiple other things. Like, checkout, we'll be talking to order management system. There is caching that is happening. If you have sensitive data in cache, what would you do? It's encrypted, not encrypted. There are different components, but like when you talk about like I said, right, the extension of an existing app. So there are certain things like authorization and check. Is it what is being leveraged even for this, or they're building their own? Like I gave an example that I did see this, the authentication or something else. So yes, definitely we do take a look at that.
Rely on documentation, or are you going to rely on developer interviews? Are you going to look at Jira tickets? Are we assuming that Jira tickets contain all the information that we need?
That's a really great question, and I still struggle with that even today. The best scenario is you have everything, right? You have everything. You have the diagrams completed. You have the Jira stories in detail. You have people available to explain it to you, right? And that's the biggest challenge that because you see, threat modeling is not you do your job and get out. You have to work with people, like product manager. So that's the challenge. And I work with multiple teams. There are teams, if they're building something, they just ping me even before it comes to me. if you build that rapport with them, I think that goes a long way. One, and you work with what you have. That's what I have learned. That whatever you have, right? If there is no, you ask them questions. And like I would do this way. You have some stories. You look at it, what, and you will have some questions. Then you send it back to them. So that's somehow, that is where it works.
Sorry, one last question. Can code be the source of truth instead of documentation? Like,
then the code is already written. Threat modeling we are trying to do typically before even code is written.
no. So the code for the e-commerce application exists. Code for the gift card application doesn't exist. So when you're asking questions about what's already existing, like what kind of authentication you is there any relation? Is there a possibility of SSRM? Are those kind of questions? Can you like look at the code, go to GitHub, understand what's going on?
Not necessarily, but to certain extent, yes. If there are no vulnerabilities, because the code is written and there is no vulnerability, right? So codes, assuming, yes, of course. Assuming that the vulnerability scanners are all in place and there is no vulnerability reported, that is one thing. And pen testing is done on already existing. Like for example, if there is a vulnerability, you can check that, right, for a given code base. But I have seen some tools that integrate and generate diagrams, leveraging the code base. I've seen that. I have not used it, but I have seen in some of the conferences that I've seen they are coming up. Like that is a threat modeling before, but this is after that. They look at the code and tell you where it is deployed and everything. So I think it's the new age, so we are getting there.
Yeah.
Okay.
Thank you.
No problem. I'm just trying to. Let me see if I can share this. Okay. So, no. Can you see my screen? Okay. Yeah. So we saw the diagram, right? Earlier, we saw the user journey. So what I was getting at that while we have this laborious, like that more like we saw all these problems, right? But if you have some tech spec, if you have the diagram, you can write a simple prompt, and this is the most simplest that I've written, like a very simple prompt, and give it the diagram and give the story. And I asked it to use the stride model. And within few seconds, minutes, like it did generate like something like it come up. I'm just going to pause here for a bit. Like if you see, right, you just write a prompt, and prompt can be this is a very simple prompt. The more the context you give to that prompt, and tell it that this is what I want, even the output to be. I want mermaid diagrams code. Please generate that as well, which you can leverage to generate attack trees, etc. So it will give you, it will spit out something. This was just an example that I was saying how you can leverage this, and you can play around if you're doing any exercise. So it'll just spit out what it thinks, and it depends on your prompt again how good the output it is generating, right? So it'll generate all these things. Like if you see, right, redeem services, attacker might attempt to, and it'll try to make sure that it is following stride, and not necessarily that this is the best output, because it depends on what context you are giving, what expectations you have. If you write a nice prompt, probably it will help you to cut down some of the things and quickly look at, and maybe everything is not valid. You can exclude all those things that are not valid and probably think you can spend your time more on some of the complex things that it has missed, right? So you are helping yourself by reducing the time. That is one thing. Another thing, like I just wanted to show this, but another thing that I wanted to show was this one. This is an open source project, Stride GPT. Okay. So what you need to do is just give the OpenAI key. You have a couple of options. This was built by Matt Adam, right? Matt Adam. Yeah. So I mean, this is still good. Like you have options to different LLMs, and you still have to do the same. Put in the diagram what you have and ask. You see here there is a GitHub repo. I haven't used this, but I don't know how it leverages that. But you describe your application and provide it the right context that this tech stack is being used. We have this different features. And you can also go here and select the kind of application you have, right? It's a desktop, mobile, etc. And then the secret, what kind of secret, very confidential, etc. Like it's trying to gauge like the severity of the app. It's internet connected or intranet, and kind of authentication you have, right? And just click on generate, and you will see that it will generate the threat model. It will also generate the attack trees, mitigation, red test cases, etc. So I think you should go back and play if you have any use cases. I think I think it's pretty cool. I think we are getting that. Threat modeling's time has come with Gen AI. It does help. I don't say that this is like the silver bullet, but you can definitely leverage to cut down some of the obvious things and spend your time focusing on the more complex and important ones. I think with that, right, I will share it. I'll hand over mic to Surgeon. He's going to talk about another kind of exercise or a project. Thank you.
All right. So far, we have been discussing about threat modeling application level changes. But oftentimes, when we work in big enterprises who are still living on, on-prem data centers, we often get a requirement where we want to threat model or where we want to review an application that is deployed on-prem to deploy it on the cloud resources. So let's take an example for that. Here we're taking a web application, but I think because our assumption here is that there is no application level change, we can continue with our use case of e-commerce application. The example that I took here was for a task management tool, but the application, whatever we are migrating, doesn't really matter because there is no app level change or code level change. So what our current setup looks like. We have the server is hosted on our Linux servers. Our databases are Postgres or MySQL, pretty common. Our authentication is done by Google OAuth. For the network, we have load balancer, firewall, which are pretty much common in handling network. There is some data sharing that has to happen with the other internal services that we have developed. And there is a third-party APIs that we are using. So that's our current setup. What we are proposing for this application to be migrated to cloud. So there are different approaches that we can take for the migration. The approach that we are taking here is a lift and shift approach. Anyone familiar with that? You're familiar with Yeah. So shift and lift is basically, or lift and shift is whatever you have in your current setup. There are no changes. There's no disruption. There's no differentiation in how user is interacting with the application, and you just migrate it to your new setup. In this scenario, new setup is our cloud. We are using GCP in this case, and we'll be using IaaS to do all of that. IaaS basically infrastructure as code. It should be seen. Yeah, like that. For the GCP services that we'll be using, will be GCP Compute Engine for our server management, Cloud SQL databases for our SQL or Postgres databases, cloud storage with KMS encryption. Cloud storage we'll be specifically using for storing our backups for our databases. Google OAuth, it's pretty much same for our previous deployment as well. Load balancers, so it's same. Google GCP has their own load balancers. And then for the WAF, we will be using Cloud Armor. Now, here's the question. If all of the services or all of the infra that our previous application and the new application is pretty much same, why exactly do we need to threat model? Anyone? Platform has been changed, yes. Like what issues?
Authorization. Whatever authorization we did on my systems can be done.
Authorization on the application level? I mean,
the assumptions on the basis of which you did your previous threat model have completely changed.
so application level changes or not?
Yeah.
It's still same.
The application's the same, but then the underlying platform has completely changed. I don't think you can do application threat modeling in isolation, considering services that it.
Yeah, so service level authorization challenges will still be there, right? That's correct. But application level will not be.
There could be interactions with the.
Yeah, exactly. Interaction between services. That's, for example, if you're taking e-commerce website, and if you're considering authorization as a threat, that would still exist in our on-prem application. I think what you and I are pretty much saying the same thing is like we have two different services, let's say Compute Engine and Cloud SQL. Now there can be relation privileges from Compute Engine to Cloud SQL, right? Is that what you're aiming at? Exactly, right, yeah. Because all of these services, they have different configurations. And moving from one platform to another platform, they can have different level of configurations that go wrong. So first exercise when we do threat model is identifying our data assets. When we talk about cloud, our data assets is user data. This is because it's an e-commerce or any other application. Our OAuth tokens, however we are generating or validating all of this when it is coming into our cloud infra. Network traffic, how is it? How are we handling that? The new load balancer with the cloud. How are we denying that? Infrastructure components, Compute Engine, Cloud SQL, our buckets, our keys, all of those are our assets in this case. And service components. Risks or potential threats could be unauthorized access to GCP resources. GCP resources could be, like we discussed before, could be our Compute Engine, could be our Cloud SQL databases, storage buckets, KMS, like key management system, anything. Data leakage. Whatever data we are processing in this scenario, for example, that data that is being, passed from the Compute Engine from our servers to our databases, like Cloud SQL databases, that's leaking of that information is a threat. Man-in-the-middle attacks. How our user is interacting now with our load balancer, with our application. If user is able to inject or sit into between that traffic, that's potential risk. Credential compromise. In this scenario, credential compromise is mostly about service account keys that we use for configuring our cloud resources. For example, default service account for Compute Engine or default service account for how compute engine interacts with the Cloud SQL. That's a risk for us. And then denial of service. We are setting up a new load balancer completely. You're setting up new servers completely, new SQL databases. If they're not set up correctly, they're not able to handle enough requests. There's a possibility that the service might become unavailable. What are the mitigations or compensating controls specifically to cloud? Unauthorized access to a GCP resource. I mean, it can happen, but we have to follow the principle of least privilege. Whenever we are configuring any service account keys, only give required permissions. Don't give admin level permissions or some permissions that are not required if your only use case is to get or list. Use bucket level policies for access provisioning. So if you are storing something in S3 bucket or in GCS buckets, give access to only those buckets, not to all the buckets in the project. Data leakage, use TLS in concept. Use CMEK, which is customer managed encryption keys, and encrypt data at rest as well. For man in the middle, you can use MTLS. MTLS is mutual TLS that you can use between different GCP servers that are interacting with each other. For credential compromise, it's a compensating control for that is like service account key rotation. It's a practice. It's not a one-time thing that you can do. Denial of service. So in GCP and any other cloud provider, we have WAF available, which can handle high level of request and then scrub data whenever they're received. So you can use that in GCP specifically. The service is called Cloud Armor. So you have to specifically set it up and attach it to your load balancer. So your load balancer doesn't act as a WAF by default. Now we have a whole doc which talks about deeply, how specific servers in GCP are configured. We can share that after this call after this workshop if you want. But while you're moving to the cloud, there are a few specific things that we need to take care of specifically, which are actually not secured by default. So when we are setting up compute engine, which is our servers, they can have public IPs, and if we are setting up load balancer, there's no reason for us to have our instances also have a public IP. So we need to ensure that they do not have public IPs unless there is a use case to have them. Default firewall rules. Now, when we are setting up, our firewalls, GCP specifically, there's certain type of traffic that is allowed by default. So depending upon the use cases, you don't have to specifically have a default allow rule in your firewalls. Service account permissions. In cloud, everything service to service communication that happens, it happens by service account. Like the service account is mostly like non-human access, I would say. So they, by default, have broad permission. For GCP, if you ask, compute engine service account has an editor level permission. And if it is compromised, it gives you access to, or it gives attacker an access to a whole lot of services. So you need to make sure that you're creating custom service accounts with very specific roles and permissions for each specific service. And cloud storage access. So by default in Google Cloud Storage, buckets can be accessible publicly unless they are specifically configured not to be available publicly. So while you're setting up, you have to make sure that they are not available or exposed to the internet. This setting is different in AWS. In AWS, recently they have shifted or they have changed that the S3 buckets will not be exposed to the internet. Any questions? Sure.
Service
Mhm.
service line. It's been well, they're listening identities.
Correct.
So you still you still believe identities.
When you say identities as
Its role.
so those are service account identities, right? So
But usually you don't have access to change the permissions of
So if you create like a custom service account, let's say, I mean, you can just give it specific roles or permissions. For example, you are creating a custom role to get the object in your storage buckets. That's it. So that would restrict you if, you know, that specific service account or, you know, identity basically that would be able to get that specific object and not any other object in that. Does that answer? Any other question? Cool. Think I will hand over to you.
So we're just about to wrap it up. Just to follow back on the takeaways, and I'm sure you had some questions, or anyone has any other questions that's unanswered. I can help you. So unfortunately, there is no single line of attack as to how do we solve any threat model problem, right? It has to be taken on a use case basis. Maybe stride, pasta, whatever you can choose, but that doesn't sort of solve as to what are the threats for any given scenario, right? So to start with, what we can do is always think like an attacker. Again, for the given scope, what do you think an attacker is behind for your infrastructure or the given scope, right? That will actually help you to trim down as to which data source, which API, and whatnot can be attacked, and what is the mitigation that you should provide with. And then how do you use that, right? So have abuse scenarios, and this is again focusing specifically on the agile methodologies. Have different use cases for abuse scenarios as to, as an attacker, what will you do, how will you do, and what will be the impact, right? That way, while in the design phase itself, that will actually help you to say that, okay, before even the developers start developing anything, writing any code, they know what to expect in terms of mitigations and how they should be developing anything, right? And on top of that, identify the counterfeits. Again, coming back to the same thing again, what is the attacker behind? Is it the data itself? Once you know it's the data, then focus on the data source. If you feel it's a scenario of what Sai mentioned in terms of redeeming any coupon codes, it's a server within a specific API, focus on that, right? For a given scope. So that will actually help you to identify the different townsvilles. So that will surely help you to do the threat model in a better way. In parallel, use different frameworks, whatever we sort of discussed, right? Leverage tools. Humanly, it's very limitation as to how much can be sort of secure, right? In a manual way. Use different sort of tools to automate, and given in an agile methodology, different tickets will come onto you, keep on piling up, right? Use PyTM, Thread Dragon, and whatnot, right? So that way you can periodically build onto your threat model. And once the project is complete, you know as to where you stand. You can always fall back as to where the security is lacking. right? And continuous threat model, right? That is where there's no standard solution, unfortunately or fortunately, for us in terms of security. So any questions that I can help you with, guys? Any use case, any scenario that comes onto your mind, anything that is random, happy to help.
Anything you would like to share about the use of Prashant?
So Tragile it is very similar to PyTM, to be honest. Again, a CLI, but that integrates with your IDE, right? So depending on which IDE you use and obviously Eclipse and stuff, right? That can actually build onto a JSON file technically. Hence, I wouldn't recommend for a newbie to start with Tragile, but rather start with PyTM. PyTM is very standard, just like English formats, the data sources equal to what and whatnot. That would be a better way to start with so that you can get a good grasp of what threat models are. And you can obviously work on different findings and threats for your organization since it's open source, right? So that would be a better way to start with. Sure. Thank you, guys. If I got any questions, always reach out to us. Thank you.